Okay. So stack is basically a linear data structure is a linear data structure where insertion and deletion are allowed only at one end. Right. This is the definition of a stack. Okay, stack is a linear data structure where insertion and deletion are allowed only at one end. Also called last in, first out. Why we call this last in, first out data set? That we will say in a, you will understand in a 2 minutes. So stack basically so let us say we want to insert certain elements. So stack basically represents our daily life of items. তোমার মাকে দেখেছো নিশ্চয়ই বাসনপত্র বাসনপত্র গুছিয়ে রাখতে, তো একটা বাসনের উপরই আরেকটা বাসন রাখা হয়, ঠিক আছে, বা একটা গ্লাসের উপরই আমরা একটা গ্লাস রাখা হয়, এইভাবে করতে করতে আমরা স্ট্যাক অফ গ্লাসেস বা স্ট্যাক অফ ডিশেস তৈরি করা হয়। The thing about this stack is that you cannot pull it from the below, right? If you pull it from the below, the whole stack of dishes or whole stack of books or whole stack of glasses fall down. That is one of the basic properties of a stack. So why? So let us see. Let us insert some elements, and then we'll understand. So we want to insert an element that is 22, 33, 44, 4, 56, 32, and 10. So the first element that we want to insert is basically 22. So what we do? So the insertion, we insert 22 first. So the 22 went inside. Went inside, right? Okay, now we have to insert 32. So now the 33 went inside. Now we have to insert 44. Now the 44 is going inside. Now we have to insert 56. Now the 56 is going inside. Okay, now we have to insert 32. Sorry. Now the 32 is gone inside. Now we have to insert 10. Now the 10 is gone inside. Right. Now all the elements have gone inside. Now we want now supposedly we want to take some element, right? So what element should be taken out? We want to execute 56, right? We want to take out 56 value out of this, right? But we cannot take it out because the insertion and deletion can take place at one place only. So the insertion also takes place from this side, and also the deletion that takes place only one side of the array only. Okay. So insertion takes place at one place and the deletion also takes place. So we have inserted till now, right? Now how to delete it? The first we have to delete 10 out. We want to get the value 56 out, so to get the value 10 out. So we take the 10 out first, right? Okay. Now we want to delete the value 32. Now the value 32 is deleted. Okay, then we can access only 56. Now the 56 value is deleted. Now so I want to take out the means we have to delete the value. Now we have deleted the value 56 value. Right. Now we have to insert the values back to it again. So the first value that is inserted is 32, and then again the value that is inserted is again 10. So that's how the insertion and deletion takes place. So the last value that goes in is the value that is first taken out of the stack. So the last value that went out was 10. So it is the value that is has to be taken out from this stack. Okay, very simple operation of stack. So this insertion and deletion of values should have a name. So the insertion is basically called pop. Sorry, insertion is basically called push. Sorry, push. The deletion is called pop operation. Right. Now, since the array is not unbounded, that means it has a finite size. So there is a element that keeps track of the size of the array. So there is a top variable which keeps the which keeps track of size of the array. Also, it represents the top element. It represents the top element of the. Now let us just try this operation again. Okay. So now again we delete it. Now what we want to do? We want to push all these values, right, from this one. So we want to push the values from left to right into this stack. So the first value that will be inserted is basically how much? Push 22. Right. So let us take this stack. Push 22. So the value that is pushed is 22. Okay. Now the next operation that we will push is, so when you are pushing 22, so initially the top value, so let us not push this first further. We will do it the operation later. Let's understand the first value. Now, if the stack represents, if you are representing the stack using an array, so let us say what is the size, maximum size of this array? Let us take this as 1, 2, 3, 4, 5, 6. So let us delete this one. Okay, so this is the maximum sizes we have to define. The max size is basically for C language, max size, let us take this as take the max size of this array as, we are taking the 6, but in 6 it will be basically C language, basically 5, 0, 1, 2, 3, 4, 5. So initially the top, where the stack is basically empty, its value, the top element value is -1. Okay. Now the operations that comes to us is basically what? Push 22. So when this push 22 comes, we have to first check whether the stack is full or not. If the stack is full, so what happens? We cannot push any more array. So let us try to push, and let us take another value in here. Okay, 98. So we want to value the push 22. So we want to value the push 22. So how to track if the value 22 can be pushed or the size of the array has reached its max position now? We will try to search the value of this one. What is the value of top element? If the value of the top element is equal to max, we cannot push anymore. Okay. But if the value of the top element is less than max, then we can push the element. In this case, the array is empty and the top element is -1. -1 represents that that there are no more elements. There are no elements. The stack is empty basically. Top -1 represents the array is empty. There is no element. Now, when you want to push 22, what you have to do? Now we know that top element represents the top element of the stack. So in this case, what we'll have with the top element's value? So since top is basically less than max, so we'll increase the top value first. Top equal to top plus 1. Okay. So top value now becomes how much? Top value becomes 0. Okay. So add 0 is a varied stack position. So stack. So now we can put stack top is equal to 22. So the push operations represents this function. If now if top is equal to max, or basically you can say top is greater than, or basically you can say max -1. So max -1 is equal to 4, greater than 4 is 5. So we can say top is greater than, or top value is equal to max, or top value is basically, let us take that, top less than max. Only then this will take place, right? If top equal to max, less than equal to max. If top is basically less than equal to max, then only we can put an element inside the stack. If I am wrong in a time, just if somebody knows it, please let me know. Okay. Okay. Now what happens? Top is less than equal to max. Yes. Top value was -1. -1 is less than equal to 5. So we put top equal to top plus 1. So -1 becomes 0. And top, the stack top becomes equal to 22. So this becomes 20. Right. Now we want to push which value? We want to push 30. Right. Now you see top is less than equal to max. Again, top's value was how much now? Top value is 0. 0 is less than equal to 5. Yes, 2. So 0's value becomes 0 equal to 0 plus 1 becomes 1. Okay. And what value we should insert? Stack 1 is equal to 33. Okay, now the value is put in here is 33. Again, for 44 also same thing happens. What is the top value? It is 1. 1 is less than equal to 5. True. So top equal to top becomes, the top value increases. And stack top becomes how much? 44. So till top equal to 5, the value is increased in order. That is 56, 32, and 10, 10. But as soon as we want to push 98, right? Okay. Sorry, this one will not less than equal to this one. So now we want to push 98, right? Now is top value is now is equal to max. Okay. Now is top less than max. So top value is 5. 5 is less than 5. False. So no more insertion will happen. Okay, understood? So initially, now if you want to push 98, so what happens? So initially top value is 5, max value is also 5, right? So we cannot increment the value. 5 is less than 5, right? So if you want to insert a 10 in here at that time, so let us say we have inserted till this point, right? 32 we have inserted, right? Now we want to insert 10 in. In that case, what is happening? 4 is less than 5. Yes, so top value can be implemented. So top value became 5, and we inserted the value that is 10 in here. But now if you want to insert 98, now we want to push 98. What will happen? 5 is not less than equal to 5. 5 is equal to 5, but 5 is not less than 5. So 5 is less than 5. That is false. So top cannot be incremented. So we'll write else. We'll just print out a statement. Over. Did you understand it? Okay, any more questions regarding push operation? We will go into the pop operation. Any question? You can unmute yourself and ask. Okay. So till the stack is now the stack is complete, right? Now we want to pop all the elements, right? We want to empty the elements. So we will just do popping. Okay, so we'll just keep this element pushing the side track, and we'll start our popping operation. So initially we want to only apply pop operation. So pop operation is possible till what point? Till the element is till the stack is empty. Okay. So how to take the position? If the element is empty, array on the top is basically empty or not until it reaches the value -1. Okay, so this is our pop operation, and what is this basically? If top value equals to minus 1. If top value is minus 1, we will say that no more is possible and basically we will do exit. Otherwise, we will return the top element. So what is the top element basically? Else now else if the top element is not equal to minus 1, then what will happen? So basically we will decrement the top value. So we'll first return value basically we'll do what? Value is equal to top. Okay. And we'll decrement the top value. And we return the value. Return the value. That's right, return value. So now let us write so the first operation will return what? 10. So if we execute the pop operation, what will happen? So if top is equal to minus 1, top value is maximum. Top equal to 5. So it will not execute the if statement, it will execute the else statement. Else if statement, what it will return? Value is equal to top. That is stack top value. Right. Sorry about that. Stack value is equal to stack top. Right. So what is the stack top value? 10. Right. The value is basically returned. So if you change the the array, basically values are still there, but if you are changing the top side, it represents that that is the value of top. Now top becomes value what? Top equal to top minus 1 becomes what? 4. So now top represents this element. 4. Now if you again execute the pop statement, again the 32 is returned. So top value becomes 3. Again, if you are executing the basically again executing the pop operation, so 56 is written. Top value becomes minus 1. That is, it becomes 2. Okay. Now, if you are again executing the pop operation, 44 is written, and top value becomes 1. Again, if you are executing pop operation, so top value becomes 0. Right. And finally, again, you have to execute the top operation. So the value becomes minus 1 and the array becomes empty. So what will happen? Again, if you are executing pop operation, the value is top minus 1. So you cannot execute pop operation. You have to exit. Or you can write printf underflow. That is how the stacks work. So any questions regarding this one, regarding the stack? Any question regarding stack? I presume that you all have understood. I presume that you all have understood. So write yes, no, do not write yes. Write no if you have not understood. Write only no if you have not understood. Write known if you have not understood. আচ্ছা অরুণাভ বুঝতে পারোনি? প্রণয় বুঝতে পারোনি? Okay, so now let us look into why are stacks important. Very useful in the computer recursive operations. So function calls. When you're developing, if you're developing any language, so very important to have stacks. Another of the very important stack operation is that is infix equation, infix to prefix. So basically, if there any equation is there, you have to convert it into any other form for solution. So you can just infix to prefix or postfix. Okay. Another very important operation of solution is solution of computer. Solution of mathematical. So these are the areas where stacks are very important. Function calls, when you are studying recursion, we will deal with stacks, right? So today we will deal with infix to postfix operation. So let us take infix operation, and we will convert it into another type of postfix operation. Why is required? We will deal with it later. So let us take an operation and try to solve it. So 9, let us say, plus 5 into 7 minus 6 to the power of 2 plus 50 by. Okay. So how to convert it into a postfix operation? Postfix operation, we will basically let us Today evening, do you all have time? Today evening, do you have time?
So we have C++ labs from 5:30.
Okay, any more time if you have?
Today, I don't know, sir. Arnav sir will take from 5:30 onwards.